Okay, next up, we'd like to figure out which one of these reactions are redox. And so we need to understand what a redox reaction is. So there's two parts to this word, the red and the ox. And the red comes from reduction, and the ox comes from oxidation. So a redox reaction is where both of these are taking place. And a quick way to remember what these mean is to just use the acronym OILRIG, and that just means oxidation is the loss of electrons, and reduction is the gain of electrons. And so in redox reactions, you will have oxidizing agents. This will be the species responsible for oxidizing another one. So that means it is responsible for another compound losing electrons, which means it must be gaining electrons itself. So it is reduced. So the oxidizing agent gains electrons, and the reducing agent is responsible for reducing another species, which means it is responsible for another species gaining electrons, which means itself it must lose those electrons. And so we're just going to go through A to D and see if we have any indication of electrons moving around between two species. And so with A, we have Al, solid, plus 3Ag to become Al 3 plus 3Ag, solid. So we're going to split this into two. We're going to analyze what happens with the aluminum, and then we analyze what happens with the silver. And so with the aluminum, it's going from Al solid to Al3 plus. We know we must balance out the charge, and so we have a net charge of 0 here, a net charge of 3 plus here. If we're balancing that out with electrons, that means we add 3 electrons at the end. Next up, we analyze the silver one, and we get 3Ag plus aqueous into 3Ag solid. Again, we need to balance out the charge. We have 3 plus here, 0 here, so we're just going to add 3 electrons here. And so we can see that there has been a transfer of electrons. Aluminum lost electrons, so aluminum was our reducing agent. And silver gained electrons, so silver was our oxidizing agent. And so A qualifies as a redox reaction. Next up, let's check out B. We have SO3 gas plus H2O liquid to sulfuric acid. Now, by just looking at what this product is, so sulfuric acid is a covalent bond. They're covalent bonds within sulfuric acid. And so electrons are not being transferred because covalent bonds imply that they're sharing electrons. And so already I can tell that there will be no reduction, no loss or gain of electrons. Electrons will simply move between the atoms. And so this will not qualify as a redox reaction. Next up, I'm going to study C. Okay, so this is not a covalent product, and so I can't immediately say that it is not a redox reaction, so I just need to analyze what's happening. So Ba and BaCl2, that becomes Ba2 plus. And then Cl2 is becoming 2Cl minus. And so now I balance that with electrons, so this I'll add 2 electrons. So yeah, I will add 2 electrons so that I have, sorry, not to that side. I have a net charge of 0 here, and I want a net charge of 0 here. So I add 2 electrons to this side. And with the Cl2, I have 2 minus charge here, so I'm going to create a 2 minus charge here, so I can add 2 electrons to this side. And so here I can clearly see that the Ba lost electrons, and so it was my, according to how we've defined it, my reducing agent. And chlorine was my oxidizing agent. And so this does qualify as a redox reaction. Now lastly, let's check out C. We have solid magnesium plus liquid bromine to become magnesium bromide. And so again, this is not a covalent product, and so I just need to analyze what's happening with the electrons to form this ionic bond. So who's losing the electrons and who's gaining them, because ionic implies the loss and gain, or the transfer of electrons. And so I'm going from Mg solid to Mg2 plus. And I am going from Br2 Br2 to Br minus. And so if I want to balance out the charges on both sides, I'll add 2 electrons. So I have 0, 0 on both sides. And here I have 0, minus 2. And so I'll add 2 electrons here. And so based off of this, I can see that the magnesium lost electrons, so it was my reducing agent, and the bromine gained electrons, so it was my oxidizing agent, which means that this also qualifies. And so A, C, and D are all going to be redox reactions.